Okay, so 2016 number 5, we have a funnel. The inside height is 10 inches. So the overall height is 10. At each height, the radius is given by that function. So they give you a function to represent the radius. For h's okay, so inches are units. Units are inches. Okay, A, find the average value of the radius. And this problem, I think, was fairly low scoring, mainly because of the presentation. Two of the questions, or part A, is very, very straightforward. The average value, well, this is an average value theorem question, and we're measuring the average of the radius, and radius is a function of height. They give you a function for radius, so the average value would be 1 over, and if you want to be explicitly clear, it's 10 minus 0, because that is my change in h's, from 0 to 10 of 1/20th 3 plus h squared dh, and then we would evaluate that integral, which would be fairly straightforward. The 1 over 20 is just a constant. I would actually pull that out and stick that with the 1 over 10 in front to give me a 1 over 200, and then the antiderivative of 3 plus h squared is 3h plus h cubed over 3. We'll evaluate that from 0 to 10. And then that would give me a final answer of 1 over 200. And then I'll plug in 10. So 3 times 10 is 30. Plus 10 cubed is 1,000. But that might be the kind of thing that I'll do something stupid with and maybe write 100. So I'm going to leave it as 10 cubed over 3. And if I plug in zeros, 3 times 0 plus 0 cubed, and I am leaving my answer like this. I will include units because we did find the average of the radius, and the average radius would be measured in inches, and I'm going to stop right there. I will not attempt to clean that up because there is no advantage in doing so. If they ask us to interpret it, or if we have to use this answer later, then we'll come back and evaluate that. Leave it as is, though. So for part B, find the volume. Every time we find volume in AP Calculus, it's going to be by finding the area of a cross-section and adding that area as if we were stacking it up. So our cross-sections this time are horizontal, and we do not have an X or a Y axis. Instead, we have an H axis and an R axis. And so in my mind, H is like Y and R is like my X. So that's kind of how we're looking at this. And so my cross sections, they're horizontal and they're perpendicular to the H axis. And so this would be a DH problem. So we're going to do this with respect to H, and my area of the cross section is a circle. Now, in the world of volumes, we call that a disk, and the area of a disk is pi r squared. And what I have to do is get my radius in terms of the variable we're choosing, which is h, and that's going to be absurdly easy because my volume, or my radius, is given to me. The radius is already a function of h. So that's going to be 1/20th of 3 plus h squared. And all we have left to do to get the volume is we measure that area. I'm going to pull the pi out. R is 1/20th of 3 plus h squared. We're going to square that, and then we're going to measure it from 0 to 10. So we do the antiderivative of the area formula, and so now we're going to work this antiderivative out. 1 over 20 squared is 1 over 400, and I'm going to pull that constant out, so I'm going to make that 1 over 400 times pi. And then I will need to square 3 plus h squared, so it's going to be 9 plus 6h squared plus h cubed to the 4th, dh. And that's going to be the hardest part. The integration of this is going to be fairly straightforward. So pi over 400, that'll be 9h plus 6h cubed over 3 is 2h cubed plus h to the 5th over 5. We'll evaluate that from 0 to 10. And I'm going to do the same thing I did in part A. I'm not going to simplify this in the least. So it's going to be pi over 400 times 9 times 10. Okay, I said I'm not going to simplify it in the least. I will do 9 times 10. That's 90 plus 2 times 10 cubed plus 10 to the 5th over 5. And if you plug in 0 for your h's, you get a 0 in return. And so there is your answer for part B. And I'm going to angle that because the sun is putting a huge glare on me. There, that's a little better. Okay, so there is part B, and there is only a part C remaining. Okay, so the funnel contains liquid that is draining from the bottom. At the instant when the height is 3 inches, the radius of the surface is decreasing at 1/5 inch per second. What is the rate of change in the height with respect to time? This is a related rates problem. So now they squeezed in related rates. And so when I'm doing related rates, anytime they give me a dimension, I always want to know, is that dimension constant or is it changing? And my height is not always 3. So I'm going to say that the height is 3 inches, but it's only for a split second. So I put that in a little flashbulb, PAL, Batman thing to remind myself that that is changing. The radius is decreasing. So that is a reference to the derivative of the radius. So dr dt is decreasing. So negative 1/5 inches per second. At this instant, what is the rate of change of the height? So we're trying to find dh dt at this time. And so there is all the information from the paragraph. And now we need a formula that ties R and H together, which is pretty easy because they gave that to us. So 1/20th, 3 plus H squared is my R formula. And we need to do the derivative of this with respect to T. So this will be an implicit differentiation. I'm going to leave the 1/20th alone. The derivative of 3 is 0. The derivative of H squared is 2H. But we have to remember to multiply by dH dt. And the rest is fairly straightforward. We just plug in what we know. Now that I have taken the derivative, I can use the 3 inches for H. So dr is negative 1/5. I'm going to simplify this a little bit. The 2 and the 20 will reduce to 1/10. And I'm only doing that because it'll make the arithmetic a little bit easier when I solve for dh. I'm going to plug in my h of 3. And dH dt is unknown. And I tell you what, I'm pretty lazy on these. You do not get extra points for having a nice, clean, sexy, simplified answer. So I'm going to leave my answer as negative 1/5 over 1/10 times 3 is 3/10. So I would probably go ahead and change that to 3/10. Always, always, always include units. And to get units in a related rates problem, I just look at what I found. I found height over time, dH dt. Height would be measured in inches. And the time in this problem, I got to go back here, is seconds. So time is seconds. And so I would leave my answer like this. I would not simplify that. I would stop because that is an acceptable answer. Excuse me. However, if you're an overachiever and you wanted to simplify that, that'll be 1/5 times 10 thirds, which would reduce to negative 2 thirds inches per second. Again, there's no need to do that. You can only screw yourself up. So I would encourage you to stop as soon as you are down to only arithmetic.